Hello and welcome. Today I will show you how easy it is with platform.sh to deploy Shopware's app example and basically make the whole hosting part very easy to deal with. We will have a look on how this application actually deploys to platform.sh, how the workflow looks like, how we can introduce a change, and how it is connected with Shopware. So I already prepared a new project on platform.sh that is actually based on Shopware's app example repository. This already includes all the necessary configuration that platform.sh needs for deploying your application. But let's get one step back. Platform.sh basically abstracts infrastructure for you. So you don't need to worry about the details of setting up cloud infrastructure. You have all the goodness when it comes to scaling, governance, securing a secure platform, and very easy deployments. We will see how that goes. We work with multiple cloud providers. So here I have a region that is actually based on AWS, but we have others that are based on GCP, OVH in France even, or of course Azure. So you really have the choice where you want to go, and there's no limitation whatsoever. You always interact with our API, our interface, our abstraction layer, and the experience is the same on all those cloud providers. We have different regions all over the world, so we will be able to deploy your application close to where your audience lives or where your team lives. So as I said, I already prepared a project where we have the application example running. Everything on platform.sh is based on Git. So we saw that I just used the Git repository from GitHub and used Shopware's app example. And this is where all the configuration lives in. So let's have a look on how that looks like. So we can basically jump into our services UI here and go through the application, the routes, and the different services. So I will show you the configuration actually in the YAML config. That's the same file that you will find in the repository. So the first one we are looking at is the .platform.app YAML file. I'm not going to spend too much time going into all the details, but you can imagine this as the description of your application. So here I give my application a name, I declare the runtime in this case that I want to run. Here it's PHP 7.3. What you see here is that you only need to define PHP 7.3. So you don't need to worry about all the latest security fixes, patches. You only need to worry about the major and minor version, and everything else will be taken care of. So with every deployment, you just get the latest version of the runtime that you declare here. We will never automatically upgrade you from 7.3 to 7.4 or either 8.0. This is totally up to you, but everything else is just managed for you, so you don't need to worry about the security. We have some static environment variables here as an example for this demo. You can see that there's a hook-based system where you can run certain actions like caching, clearing the cache, or installing some assets for the Symfony project at certain steps of the build, the deployment, or others. We open a connection to our database that is declared in another file. We add some disk space for any potential files, and those files will live in, for example, those mounts. Mounts is where you can declare basically write access. Everything else on the file system by default is read-only. And then we have some basic web server configuration. In this case, it's quite straightforward. We basically tell the system that in our public directory, there's an index.php file, and this is basically our controller where all the traffic will be incoming. So that's our application. In this case, since we use the Shopware example, we use PHP. But of course, platform.sh supports other technologies. So you can write your application in JavaScript, run it in a Node.js container. You can run it in Java, even in .NET, in Lisp if you want to go exotic. Of course, we also have Python or Ruby, for example, amongst others. I already mentioned that we have a database here. All those services, like a database, a Elasticsearch, a Redis cache, for example, those are defined in a different file. That is called the services YAML file. And this configuration is even easier. It works the same way than our application file. We have a type of a certain database. In this case, we're using MariaDB. As I said, we have others. There's a full list in our documentation. And for the version, there's the same principle that I just explained on the PHP level. So you only need to worry about major minor version. Everything else is taken care of. And since the database needs to store some data on a persistent layer, we also need to define some disk space. The last important file is the routes configuration. It's called the routes YAML. And here again, it is straightforward for this demo. Basically, we tell the system that every traffic that's incoming on our domain, it will end up into our application. There's a redirect here for the www route. We could add more complex redirect rules if we want to use regex, for example, to do some redirects or some more caching configuration. That would all live in this routes YAML. And with those files, we can already deploy something to platform.sh. So if you take those, push them to a repository that is connected to platform.sh, and that can be either live directly on platform.sh or in GitHub, GitLab, or Bitbucket, etc. So as I said, I already took the liberty to deploy this application. I went even one step further and also installed a Shopware instance in another platform.sh project. So the same principles, of course, the YAML files will look a little bit different, but you can, of course, deploy anything on platform.sh. So when we open our production site and jump into the admin panel, we will see that based on the manifest XML that I created, we will already see, oops, seconds to load. We will already see that I have my platform.sh demo application, which is based on the app example from Shopware. So I have my order list for one of the orders here already, and those are connected. So basically the backend application, the production side of my shop, is connected to the production environment of my client application. So let's try to introduce a code change, because let's say we want to change something in our application. For that, I'm going to actually jump to the terminal really quick, and we'll use the platform CLI to create a new branch. So I'm basically working in the local copy of my repository for my client application. I create a new branch that is called Deploy Friday. So why am I using the CLI? The platform CLI is actually a wrapper around certain open source tools in our API. So it can do a couple of things at the same time. Here I'm creating the new branch, since that's something I would usually do when I create a new feature. I want to work on a new feature. But it does a couple of other things. It also creates this branch as an environment on my platform.sh project. So I see that not only do I have my production environment here, but a new environment based on our Deploy Friday branch. What I will get here, and that's running within a couple of minutes, is a completely new environment. So we are already seeing that the system is deploying a new domain for this environment. And we also see that while creating this environment, it is actually cloning its parent environment. What does that mean? That means that since we are branching off of our main branch, the production environment, all the data will be available in our Deploy Friday environment. And all the data means all the data. So I have the complete content of my database. I have all the files that have been uploaded, if there are any. If I have Elasticsearch, I would have my search index ready to use. If I had a Redis cache, it would even clone the state of the Redis cache and have that available on this environment. And while it's based on the parent environment, it is not sharing any resources of the production environment. It runs completely separated on different infrastructure, making sure that nothing is impacting the production side, of course. Regardless of the size of the data, this will always only take a couple of minutes. So we don't need to wait for like hundreds of gigabytes to be transferred. It is always within a couple of minutes due to the technology that we use underneath. So we see that the data is already cloned and the new environment is starting right now. This means that as a developer, I can basically get, just by creating a new Git branch, I can get a new separated, completely isolated environment that is based off my parent environment and with all the cloned data. I don't need to open any DevOps ticket. I don't need to create a new server somewhere. I can just create a new branch and that's it. No, I'm completely flexible on that. And again, here we are using a little bit of a simplified workflow. It's just creating a new branch. It could be a different action. It could be opening a pull request on your GitHub repository, and then automatically you get back a environment based on that pull request. And you are totally flexible in your workflow. So this is again an example that I used for this Git branch, but you could also set up more complex hierarchies, like having a production setup, a staging branch, feature branches, or sprint environments underneath that. But you're not limited to this. You're not limited to a static staging environment that will block your whole workflow because there are features that you need to be approved on the staging system first before you can move on. So let's say you have 2 developers working on 3 different features. 2 of them are already approved on the staging, but the 3rd one still has a bug. So you can't really deploy the others. With platform.sh, you're way more flexible since everything is just based on those Git branches, basically. With the new environment ready, we can make our code change, because right now we just created a clone of the existing page, of the existing project, but we haven't made any code changes yet. So here I opened my local development environment. So we'll see the source code of the example app. We are seeing our YAML configuration file here. That's the one I touched base on before. There's the routes YAML and the services YAML as well. But here we are going to jump into the Twig template file, and we will try to make some change here as an example. Again, this is a placeholder for the sake of this demo. So I will just, add a new headline here. For example, let's say, put in this, put in deploy Friday, and this will be our code change. It can be really anything. It can be an update of a composer package. It can be your new feature, of course, any changes to your PHP code, any change to the code you can think of. Here, it's of course a very simple example of something visible, so we have something to see. So what I need to do right now is commit this to my Git branch and deploy that to platform.sh. So we will see that this one file is actually the only one that we modified so far, so no other change in our code. We will add this to our repository. We will commit it, of course. Add no headline to template. Leave a git commit message, and then we push this to platform.sh. As I said right in the beginning of our presentation, everything is based on Git, and so are deployments. And we've seen that before, but here it is really the push that is triggering a new deployment. So what we see happening right now is that on our existing deploy Friday environment, we are rebuilding the application container. Rebuilding the application container means it will execute all the steps necessary, and this depends, of course, on the configuration and the runtimes you use. So here, based on PHP, since we have a composer project, it will use the composer JSON file and the composer log file to install all the different dependencies and run all the different steps necessary that we defined afterwards. So remember those hooks in the build process, those will be executed afterwards. Again, this is the example for PHP. If we would be talking about a Node.js project, it would probably run npm install and other package managers for other runtimes, for example. This is the default, but again, you have the flexibility to define this completely custom, so you can put in your complete custom composer install command, for example, and make this work with your specific needs. Then this is basically the artifact, so the container is then used to be deployed to our environment. So we will briefly remove the old container, put in the new container, and then we should have our new application ready to use. So of course, this is all based on the git push that I did right now. It could also be based on the pull request that I updated or any other action that I defined. We also see that not only our build hook is executed, but of course also our deploy hook. So remember when we had this assets install and the cache clearing command, that's of course now also executed here before the application is ready for us to use. With our application now deployed, we can check how it looks like. To be extra safe, I will run the uninstall and install process again on our staging environment for the shop, just to double check that we really have the latest version. Since I'm no Shopware expert, you probably know already that this is not necessary, so you know more than me. So switching back from our client side to the backend again to the Shopware installation, I have done the same thing. I have our production environment and we also have a staging environment where we want to check new features first before we deploy them actually. So this is the same principle. I have this own environment on its own separated domain just for the staging setup of my Shopware backend system. So I can jump into the admin panel here, and I also have the app installed since I just reinstalled it. Check the demo application and I can see that now I have my Deploy Friday headline visible. So that's the code change we made on the other side, on our client side, on the application, on our Deploy Friday branch. So that's connected. Of course, our production setup is not connected to the Deploy Friday branch just yet. So we can basically take that URL, send that to all our stakeholders, the product owner, our QA team, the end customer if we are an agency maybe, and have them check everything. So they can check our new application change, make sure the new feature that we developed works. They can give us very quickly feedback so we can iterate quite interactively, make changes and send it back and forth. We can even fix any potential bugs that we introduced by just committing code again to my Deploy Friday branch, pushing it again, and it will be updated. So we can talk with our stakeholders about the same thing because we are actually working on the same thing. So at some point, we will hopefully get the feedback that all is good and we can deploy that to production. Deploying to production, again, it is based on Git, so it would be accepting your pull request, it would be merging the Deploy Friday branch into main locally and then pushing it to the production side, but we can also just use the user interface, hit the merge button and merge that into the production environment. So now I'm back on my client application on the platform.sh project, and I triggered a deployment from our deploy Friday branch to the main branch. So all of the code changes will now be also deployed to the production branch and will be available on our Shopware environment. In this case, since we are on the production environment here on our app side and the production environment here on our Shopware backend, this will be, of course, in the production setup. So I hope this gave you a really first insight on how easy it is to develop something, a Shopware application on platform.sh, how easy it is to deploy, how easy it is to make changes, and to not worry about infrastructure at all. Thank you.